Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 1-methyl-3-chloro-3-isopropyl-cyclohexane. The Cl is at C3, tertiary carbon, bearing both the Cl and the isopropyl group. Now it is a strong, bulky base that promotes E2 elimination. Moving on to the next step. From the tertiary C3 bearing Cl, the adjacent carbons, C2 and C4, carry beta hydrogens. Elimination toward C2 gives a double bond between C2 and C3, endocyclic, and elimination toward C4 gives a double bond between C3 and C4, endocyclic. There is no gamma hydrogen pathway for exocyclic alkene from these positions under normal E2. Moving on to the next step. E2 with now it, moderately bulky, follows Zaitsev's rule, favoring the more substituted, more stable alkene. The double bond between C3 and C4 in the ring, where C3 also bears the isopropyl group, gives a trisubstituted endocyclic alkene. The double bond between C2 and C3 gives a less substituted endocyclic alkene. And for the final step, E2 requires antiperiplanar geometry between the H and the leaving group, Cl. The conformation of the cyclohexane ring and the stereochemistry, both CH3 at C1 and Cl at C3 on wedge, isopropyl on dash at C3, determines which beta H is anti to Cl. The antiperiplanar H at C4 relative to the Cl at C3 satisfies this requirement, giving elimination toward C4. Elimination of HCl using the H at C4 gives a cyclohexene with the double bond between C3 and C4 retaining the CH3 wedge up at C1 and the isopropyl group adjacent to the double bond. This corresponds to option A1 methyl 4 isopropyl cyclohex 3Na P menth 3Na type with CH3 up at C1. Option B shows a different regiochemistry of the double bond inconsistent with the preferred antiperiplanar elimination. Options C and D show exocyclic double bonds is equal to CMe or is equal to CH2, which would require elimination of a methyl or isopropyl CH, not a ring CH. These are not favored under standard E2 conditions with now it. Therefore, the correct answer is A. Therefore, the correct answer is option A.